Good morning, Robert Scribbler here with the April 17th session of the OBX Wave Report. I am here to discuss with you all things waves, weather, climate, and the beaches. And for today, we're going to talk a little bit more about climate. We're going to get into a bit of a preamble climate discussion inspired by a recent interview with Dr. Michael Mann. I've provided the link to Dr. Michael Mann's interview in the description of this video, and I encourage you to go check it out. It's a fellow YouTuber who YouTube's primarily on the issue of climate change and discussed extreme weather, carbon dioxide, and in particular, certain kinds of extreme weather events that are now being enhanced by the climate crisis, which is driven by fossil fuel burning. But I would like to just note that this time of year is the time of year when we start to get new global carbon dioxide reading records because we are transitioning from northern hemisphere winter into spring and summer, and the trees haven't yet come into full bloom. So the carbon dioxide has had its chance to accumulate in the atmosphere without the drawdown that occurs from the respiration of plants. And so we are hitting near maximum levels of CO2 for this time of year. We'll hit a new maximum sometime between April and May for this year. But right now, the latest CO2 readings at the Mauna Loa Observatory is in the range of 423.84 parts per million. And that is an extraordinary departure from past times. I'm going to go ahead and just show you the 1700 to present record. So you can see the rapid increase in carbon dioxide with the start of fossil fuel burning in the mid to late 19th century, and then the rapid expansion of fossil fuel burning in the middle of the 20th century that right now continues through today. But we have the opportunity to get off of that track now with clean energy being more and more available. But as we start to get out into geological times, the departure caused by fossil fuel burning, the departure of CO2 in the atmosphere from normal, the rapid increase of CO2 becomes more and more apparent the further we look back in time. So if we look back 10,000 years, the increase in fossil fuels over recent centuries is apparent more as almost a straight line up in the graph. And then as we look back to 800,000 years, we see that presently carbon dioxide is out of context for the period that has included most of the transitions from glacial to interglacial periods over the last 800,000 years, and carbon dioxide levels are likely higher than they've been at any time in the last 3 million years or more, according to recent reports. I'm not going to dig into paleoclimate in depth. I'm not going to dig into carbon dioxide equivalents in depth in this video, but I did want to show you how unprecedented the departure is, and what fossil fuels are doing to our atmosphere is pretty freakish. It's kind of Frankenstein, Godzilla, nasty kind of thing. It's not good. Carbon dioxide is not a harmless gas when it comes to our climate. It traps more heat in the atmosphere and more heat in the lower atmosphere, which causes a lot of variance between not just not a lot of variance, not just from past temperatures as the global system warms, but you also get a lot of variance in the global system where you get hot areas juxtaposed to colder areas. And it's that difference in temperature and that added heat energy that helps to drive storms. And that's one of the reasons why I wanted to highlight a couple of things. Recently, we had a deluge in South Florida that is now being called a 1,000-year storm, but we know it's not. It's not a 1,000-year storm anymore because the added heat in the atmosphere has loaded the dice for more extreme events like the deluge that recently hit South Florida. It's much more likely that these events will occur now that the atmosphere has warmed up, that the lower atmosphere has warmed up by about 1.2 or 1.3 degrees Celsius above the 1880s to 1920s temperature range. The added heat has added evaporation from the land surface and the ocean surface, and in particular for Florida, the Gulf of Mexico is much warmer than normal, which is providing more fuel for thunderstorms and supercell thunderstorms. And this increases the peak potential strength of the storms. And because we have the opportunity for those storms to get stronger, sometimes the weather dice will roll in favor of getting those more extreme events. So we've got this extreme 25.9 inches of rain over 8 hours in Fort Lauderdale that occurred recently. And that storm event was enhanced by the extra heat in the atmosphere. It was made more likely, and it would not have happened the way it did in a normal atmosphere. The reason why I'm talking about this today is because Dr. Michael Mann had this discussion on YouTube and talking about extreme weather and climate change. Again, I've added the link. It's a fantastic video. I did just watch it. I encourage you to do the same. But what I'm going to do is I'm just going to break down some of the topics that are coming up, not just in this video, but in recent discussions on the issue of climate change and extreme weather. And we're going to talk about briefly about bomb cyclones, sting jets, and we've already talked a little bit about deluges. So we're going to talk about how those extreme weather events are related to climate change and talk about how these, according to the science, all of these types of features are becoming more common as fossil fuel burning warms the Earth system, and that presents greater dangers and risks to us all, which is why we all want to halt the fossil fuel burning as rapidly as possible and transition to clean energy. And it's kind of like, let's see, let's come up with some kind of analogy. It's like if your doctor tells you that smoking is harming your health, and smoking in this case being burning fossil fuels and emitting CO2 in the atmosphere, this is, of course, an analogy, a comparison with climate change. But if you stop smoking, you might still have some health impacts, but your health impacts won't be as bad. That's basically where we are when it comes to climate. The fossil fuel burning has already caused some damage to the Earth, just as smoking over a long period of time will tend to cause damage to an individual person's lungs. And the doctors, in this case, Dr. Michael Mann and the climate scientists are saying, hey, we got to stop it or it's going to get worse. It's already gotten worse, but it can still get much worse if we keep doing it. And some of the effects, some of the damage to the climate system comes in the form of these extreme weather events. And one of the extreme weather events that have been in recent news is this notion of a sting jet. So what is a sting jet? Now, there's a climate impact on the rapid intensification of storm systems and the increased potential for strong winds in cyclone events. And the reason is that as the lower atmosphere warms, you have more force in the form of convective lift coming from the Earth's surface. Now, that convective lift, is a generator for storm intensity in and of itself, but it also displaces air masses. It moves air masses around, and it has a tendency with that extra force of a warm lower atmosphere coming into contact with a cold upper atmosphere, and you can get more in the way of what they call like vertical wave variance in the atmosphere. And what a sting jet is basically it's this falling column of cold, dry air at the center of a storm system that creates a gradient between warmer air, warmer moist air, and enhances wind speed in a certain type of cyclone, a cold core kind of cyclone. These kinds of cyclones typically occur in the middle latitudes. They're one of the major cyclones that affects Europe and England, for example. And it's another kind of cyclonic feature to storm systems. It's like kind of a smaller feature, but one that can produce extreme wind events. And um, so I'm just going to go ahead and read this. This is from the Met Office. What is a sting jet? A sting jet is an isolated area of particularly strong and damaging wind. A jet of fast-moving, cold, dry air descends from higher in the atmosphere, accelerating as it descends and hits the ground near the center of the depression, so near the center of the low pressure cell, right? Sting jets are found in depressions, which are slightly different to the classical Norwegian model of depressions. In depressions with sting jets, there is a gap or fracture between the fronts, which has led to them also being known as poisonous tail or bent back occlusions. So it is a specific kind of cyclonic feature where the colder, drier air from the upper atmosphere finds a gap in the lower atmosphere in these storms and falls rapidly and helps to rapidly intensify the winds. Now, I mean, this is a subfeature of cyclonic systems generally with climate change because you have that increased energy in the lower atmosphere coming from that convective force. You tend to have you can tend to have stronger storms that hit a higher peak potential, but you can also have more rapidly intensifying storms, things that are called bomb cyclones. And so a sting jet can be a feature of a certain kind of cyclonic system that may be rapidly intensifying or more rapidly intensifying due to climate change. Generally, but let's say like the bomb cyclone is kind of the like a larger definition that includes many kinds of cyclones. And a sting jet storm is a specific kind of storm with a specific set of features. But one of the things that has been noticed by climate scientists is that sting jet storms are more likely as the climate system warms. And this is coming from scientific studies that started in the late 2010s and have continued through now. And we've seen this notion of more sting jets in the news, particularly from the Washington Post right now, reporting on the issue of sting jet storms. So I encourage you guys to check out the Capital Weather Gang and the Washington Post and their reporting on sting jets. I'm just doing kind of a basic overview here right now. And this recent study noted that this one in physics.org news, the UK could be hit by more than double the number of storms with exceptional wind speeds, like the one that caused mayhem across southeast England in October of 1987 if global warming continues, scientists have warned. So fossil fuel burning continues, yet another form of intense storm, another form of intense cyclone that produces, this one particularly that produces powerful wind speeds will likely be enhanced. And we've already seen the enhancement of cyclones generally. We've already seen the enhancement of bomb cyclones. And we've already seen the enhancement of powerful deluges by the warming of the Earth system to 1.3 degrees Celsius above normal through the burning of fossil fuels. So yet another issue when it comes to the kinds of storms that can be enhanced by climate change and impact us. Of course, I'm also here on the coastline, on the Outer Banks, this thin strand of islands that is not very far above sea level. So when these more powerful storms form, they impact the coastline with greater intensity and can cause greater damage on the coast. And they can also be enhanced by, or their flooding effects can be enhanced by the sea level rise that is driven by the melting of land glaciers as the Earth warms, as fossil fuel burning continues. So this is the reason why we are so ardent about promoting clean energy. It's not one of those things we do for a commercial kind of reason. We're promoting clean energy as a way to save us from harm. And the transition to clean energy is so helpful in so many other ways. But we can't remove the fact that the transition to clean energy is a defense against these storms and against the sea level rise that makes them worse for coastal regions. All right, so do check out Dr. Michael Mann, check out his Twitter feed, and please listen to his public communications whenever you can. He's also a fantastic communicator in the form of written communication. I recommend you check out his books. So yeah. All right. So let's get into some of our weather observations for the OBX wave report. We're getting a little bit more into climate today because I really haven't done much in the way of climate discussion or in-depth climate discussion recently. And now with kind of small waves across the Outer Banks, I think that I can take the opportunity to talk more about climate. I think we're going to do a segment on atmospheric greenhouse gases generally this week. So maybe another in-depth discussion and analysis for you guys on atmospheric greenhouse gases right now, because we're really getting into some very worrisome ranges when it comes to the overburden of greenhouse gases primarily emitted by the fossil fuel industry. And I don't know, from my perspective, from like a threat analyst perspective, it's very worrisome, the present overburden, and I kind of have to check myself by reading the science, because I feel a sense of very deep concern. But according to the science, we've got a pathway and we need to pursue it. And that pathway being the rapid deployment of clean energy, the tamping down of fossil fuel burning, and the revitalization of the Earth's basic ability to draw down carbon by changing the way we use lands and the way we manage forests, and becoming just generally more friendly to the Earth's life support systems as a civilization, because those life support systems are friendly to us, right? Okay, so right now across the lower 48, particularly in the southeast, we just had a front pass through in here in the Outer Banks. Air temperatures are cooler. We've got winds coming in from the northwest. Air temperatures right now in the range of the upper 50s to lower to middle 60s. Highs across the Outer Banks today expected to be in the lower 70s. With those northwest winds, we've got the swell, being pushed out a little bit, but swell hasn't changed too much since yesterday. Waves in the range of 1 to 3 feet across the Outer Banks, pretty calm. You can definitely see that swirl of cloud over the Great Lakes region, and we still have some pretty strong weather events occurring across the Great Lakes right now. And across eastern Florida, we still got some thunderstorms bringing in that driving rain to parts of central and eastern Florida. In the central US, mostly clear, and out west, we've got another front moving in. We'll note that we've got little storms popping up across Mexico, and generally we've got moisture flows coming in from the Gulf of Mexico and from the Pacific warming up toward El Nino at this time. Looking at the National Weather Service radar, we can see, whoa, hello. I don't know, my mouse it wants to double click when I single click. It's annoying. Okay, so we've got this swirl of storms over the Great Lakes region, with some gale warnings over parts of the Great Lakes. And then for eastern Florida, central eastern Florida, just east of Orlando in the Titusville region, we've got looks like a severe thunderstorm warning with a powerful thunderstorm moving just east of Orlando right now and heading offshore. Let's go ahead and check out these alerts, see what's going on for Greenville. That's green. What? No, that's not Virginia. That is so odd. Okay, let's look at, yeah, Volusia County. There we go. Brevard County, Florida. We've got special marine warnings and beach hazard statements in association with some severe weather. And whoa, look at this in Southwest Florida. I didn't see this before. That looks like is that a tornado? Hmm, looks like another marine weather statement due to some severe thunderstorms coming in off the Gulf of Mexico. So definitely looking at some severe weather in Florida today, right now, up and down parts of the central coastline for Florida, and then stretching from the Gulf Coast region south of Cape Coral and running diagonally through south central Florida with looks like a powerful thunderstorm cell moving toward Fort Lauderdale again. Hopefully that one won't get stuck just like the other ones did. It looks like these storms are moving, so I don't think Fort Lauderdale is in for an 8-hour period of inundation. Let's hope not. But please pay attention to your local weather experts and your emergency management folk and do what you can to protect life if severe weather does threaten. Okay, so getting to the enhanced cloud tops, you can see the stalled front just offshore, the swirl of storminess over the Great Lakes, another storm moving in through the Pacific Northwest, and I'm calling attention to these thunderstorms in the tropics right now off the east coast of South America, over in northern South America region, but in particular, a very large cluster of storms in the eastern equatorial Pacific with a moisture flow streaming in across Mexico and Texas. And then so we're getting moisture coming in from the Pacific, moisture coming in from the Gulf of Mexico. So we have that atmospheric loading for potential severe weather, including supercell thunderstorms over most of the southeast. Even though right now for today, I don't think there's much in the way of severe weather expected, but looking at the convective outlooks, looks like we're heating up by day 3 time frame, and we'll get into that a little bit more. I did want to show you once again the ocean surface temperatures. The global ocean is just really, really, really hot. It's at record heat levels recently, and the North Atlantic is one of the regions where the heat is extreme and exceptional. We've been talking a lot about the Gulf of Mexico, but just the North Atlantic in general, much warmer than normal. As we get into hurricane season, this is a major driver of storms. So even though we're looking at El Nino in the eastern equatorial Pacific, which tends to enhance wind shear that tears cyclones apart and keeps them from forming, that extra heat is weighing in on the other side of the scale. So we've got two competing influences: El Nino, which typically tamps down storm formation. And so El Nino tamping down storm formation through the wind shear effect over the North Atlantic, and then the hot ocean waters pushing against that. So we've got two competing forces for hurricane season 2023, and the hurricane monitors are trying to crunch this data and figure out where we're going to be for 2023. And it looks like we're going to get an average season. So, according to the forecast, of course, it could swing. So, because there's a lot of uncertainty given these two countervailing influences, but if the net result from global warming is that an El Nino year is a normal year for hurricanes in the North Atlantic, then buckle your chin straps, baby, because La Nina years are going to be something else. And wow, we're here right on the front lines in the Outer Banks, so I guess I'm going to be buckling my chin strap as well. I got a little helmet here. I'm gonna have to buckle my chin strap with my surf helmet. All right. So yeah, it's looking really hot out there in the North Atlantic, and boy, are these sea surface temperatures popping in the eastern equatorial Pacific as well. Let's get to Fahrenheit. Saw some temperatures near 10 degrees above normal down in the eastern equatorial Pacific a couple days ago. And we're still in the 9.5 degree Fahrenheit above normal range in some locations here, just off the west coast of South America. And this pool of much warmer than normal, if we continue the transition to El Nino, will broaden and move across the equatorial Pacific here. And that's the kind of feature that we're seeing right now. We got this wave of heat moving under the surface of the ocean, this big old, long form wave called the Kelvin wave, and it's carrying that heat up to the surface in the equatorial Pacific, and then that heat, if we continue the trend toward El Nino, will spread across the equatorial Pacific. All right, so getting to our, oops, oh, that's annoying. All right. All right, let's go to Google Maps. And we're going to do our wave observations for Jeanette's Pier and southward. And let's go, yep, and let's go to satellite. It's going to start at Manio because that's where I am. Okay, so looking at Jeanette's Pier, we've got wave heights right now in the range of 1 foot. I'm going to say it's 1 foot plus because the primary swell coming in at 7 seconds from the southeast is 1.7 feet at present. But yeah, about one to 1.5 foot waves at Jeanette's Pier right now, small waves. I'm going to get down into the ocean and catch some waves for you guys. Hopefully I'll get some more video. Had a fun little video of drop, pop, and drop in, bottom turn, little pop off the face. Working on my pumps and my hip motion a bit more to try and improve my wave riding skill. So primary swell coming in out of the southeast at 7 seconds. These are small waves, but at Jeanette's Pier, they tend to be rideable, at least with the Lost Rocket Redux or a longboard. So the more wave experience you get, the better you get, and that's what I'm doing. Secondary swell coming in at 9 seconds at 0.6 feet. That is out of the east-southeast. Winds out of the northwest at 20 miles per hour. That is an offshore flow. Air temperatures right now in the range of about 65 degrees Fahrenheit. It's going to warm up into the lower 70s today, according to the weather forecast. Ocean water temperatures warming up to 57 degrees Fahrenheit. Weather conditions today, sunny with highs in the lower 70s. And just to the north of us in Kill Devil Hills, we've got waves in the range of 1 to 2 foot, according to the wave monitors. I don't really think that they're likely to be much different in Kill Devil Hills than they are in Jeanette's Pier. My general experience is that most of the breaks around here tend to be about the same, but presently, according to the wave monitors, 1 to 2 feet in Kill Devil Hills, and over at Abalone Street, 0 to 1 foot. So looks like maybe 0 to 2 foot waves across the northern beaches. Heading south past Coquina Beach and Oregon Inlet, we briefly stop at S-turns where waves are in the range of 1 to 2 feet, and then we continue on to Rodanthe where waves are in the range of 1 to 2 feet as well, with a primary swell coming in out of the south-southeast at 7 seconds as a 2.5 foot swell. Secondary swell coming in at 9 seconds out of the east-southeast at 0.7 feet. Winds out of the west at 18 miles per hour. That is an offshore flow. Air temperatures 69 degrees Fahrenheit. Ocean water temperatures all the way up to 63 degrees down there at Rodanthe. So getting into the 60s, not too far to our south. You still need a wetsuit, and my wetsuit is falling apart. So I've got a new wetsuit on order coming in. I got a great bargain on a Reactor 2 from O'Neill. Not getting the high quality one right now. I think I'm going to invest in a higher quality one just prior to next season. I know, but I mean, I'm getting the bargain now. So I'm going to do a goodbye sweetheart episode on my XL. That thing is like old battle armor that has just been beaten to hell. I've surfed in it 43 times this winter. So, and then the wetsuit is old. It's from like 1997. So it's been through it with me and still hanging in there, but holes are starting to appear. So I figure it's time to retire it, but we're going to give it a great send off, and we're going to um, talk about how great the XL wetsuits are generally, and I'm really looking forward to maybe getting a 4.3 XL wetsuit for next season. I'm pretty excited about that. So we're going to talk about that. We're also going to talk about some other potential wetsuits which are environmentally friendly. All right, so ocean water temperatures at Rodanthe at 63 degrees. Weather conditions today, sunny with highs in the lower 70s. And then heading south to Avon Pier, we've got 1 to 2 foot waves as well. And then at Buxton, waves are in the range of 2 to 3 feet. 2 to 3 feet right now, with a primary swell coming in at 7 seconds out of the south-southwest at 5 feet. No secondary swell. This south-southwest swell is just basically parallel to the east-facing beach, so we're getting the wrap around there at Buxton. Winds out of the west-northwest at 18 miles per hour. That is offshore. Air temperature is 67 degrees, and so are ocean water temperatures. Weather today, sunny with highs in the lower 70s. And to our west of Buxton here at Billy Mitchell and Frisco, we've got 3 foot waves at Billy Mitchell and 3 to 4 foot waves at Frisco. So much better waves in the south facing beaches with that primary south southerly swell lingering for the region. Okay. So let's get into some climate and longer term weather predictions. And right now, the global climate system for today is 0.456 degrees Celsius above normal for the entire globe. This, of course, is warmer than the 1981 through 2010 reference period, which is an already warmer than normal period. The Arctic is heating up quite a bit today at 0.84 degrees Celsius above normal. We've got warm air invasion coming in from the North Atlantic, and looks like another warm air invasion coming in from Europe and well, more warm air invasions coming in from the European continent and from the Asian continent is pushing the center of cold up to the far north, and much warmer than normal conditions, particularly in the Svalbard region. And then for the US East, we got much warmer than normal temperatures and much warmer than normal temperatures in parts of Canada. We've got a lot of warmer than normal readings out here in northwestern Africa. Europe generally much warmer than normal. Southeast Asia looking much warmer than normal. Australia's flipped to cooler than normal. That's a respite for Australia. They had a much warmer than normal spate about a few weeks ago, so they're cooling off, which is definitely a balm for them. The tropics are heating up 0.44 degrees Celsius above normal, and we expect that trend to continue in the equatorial zone as El Nino, as the transition to El Nino is expected to continue. I do want to zoom in on the west coast of South America here to show the El Nino influence. It is kind of worth noting that the El Nino influence is basically at least in the anomaly maps, looks like it's being overshadowed by just the various hotspots driven by climate change. But nonetheless, we have that pool of warmth over the ocean and in the adjacent atmosphere, and that does play a larger role on global weather, which is one of the reasons why you find El Nino in the news, particularly as it has this gnarly handshake with climate change. All right. Climate change, of course, driven by fossil fuel burning. Getting into the 6 to 10 day temperature and precipitation outlooks, we expect near normal conditions here in the Outer Banks, below normal temperature conditions for most of the US, and above normal conditions for parts of the Southwest and Florida. Precipitation expected to be above normal, ranging from Texas all the way through the US Northeast and parts of the Pacific Northwest, with below normal precipitation through the upper central tier of the US and through parts of California, Nevada, New Mexico, and Arizona. Looking at the quantitative predictions forecast for precipitation gives us an idea where the storms may form. Looks like the Mississippi River Valley under the gun. For the most part, other regions are normal with the exception of the Pacific Northwest being stormy, and then the Southwest being dry in the 7-day forecast here based on the NOAA's Quantitative Prediction Center. For our convective outlooks today, it looks like we might get some storminess across parts of Texas. For tomorrow, looks like we expect thunderstorms for parts of the central US, but nothing too severe on tap. And then by day 3, looks like we've got some potential for severe weather in parts of Kansas, Nebraska, Iowa, and Missouri. So please, please, please pay attention to your weather forecasts and do what you can to protect life if severe weather threatens. Looking at our global forecast system model, outlook for the next week or so. Right now, we've got a front sweeping off the US East Coast and a storm system moving up through the Great Lakes. This is expected to progress offshore and into Canada, respectively, over the next 24 hours as we get into Tuesday. And then another storm system is expected to begin to form over the north central US, which then extends an area of severe weather through the upper Mississippi River Valley, Great Lakes, and then draping down toward the Gulf Coast by Friday with potential severe weather firing off once again near the like Texas through Indiana region on Friday, and then tracking eastward, firing off again looks like on Saturday more to the south and east toward the Gulf states of Texas, Louisiana, Mississippi, and then into parts of Kentucky, and then sweeping eastward across the Appalachians. And looks like by Monday here in the Outer Banks, we might get some severe weather as the front passes through. Nothing too crazy as far as wave generators in the weather forecast, and the wave forecast models unfortunately do also show that waves will tend to be smaller. So right now we've got waves in the near offshore environment in the range of about 5.5 feet off of Cape Hatteras for today. Sorry, 4.5 feet off of Cape Hatteras, generally 1 to 3 foot waves near the coastline. Looks like with those northwest winds, a lot of the swell is expected to get blown out by tomorrow. Although wave monitors still look like they're indicating 1 to 3, maybe 1 to 4, well, 1 to 4 foot waves today, tamping down to 1 to 3 foot waves tomorrow. I'm gonna have to change it to 1 to 4 foot waves because Frisco here had a 4 foot wave observation, so I'm gonna have to change my title here. But tomorrow, smaller waves generally, looks like possible blown out conditions. And then by Wednesday, it looks like small waves, but angling in from the southeast. And so better angle of swell might give some better waves for some beaches by Wednesday, but it doesn't really look too good in the local forecasts. And then by Thursday, similar conditions, 1 to 2, 1 to 3 feet for most of the Outer Banks. By Friday, it does look like with the front starting to approach, we might get some better waves. So let's hope that's the case where we get some better waves on Friday. Of course, we don't hope for terrible severe weather. We just hope for decent waves. And which is one of the reasons why at the end of all of our episodes, I'm imploring you guys to please do everything you can to help speed the transition to clean energy, uh, to protect our coastlines from the impacts of climate change, which include rising sea levels, more severe storms like we talked about earlier in this episode, and ocean acidification, which is just a very, very nasty thing. So please do that. Your lives will be better. You'll experience less harm, less trauma, less disruption. And I don't honestly know why anyone would want to inflict the terrible thing that is ramping climate crisis on themselves. It's just a nasty series of events that keeps getting more nasty the less you do to respond, and that can be tamped back considerably the more you do to respond. All right, so thanks for joining me for this session of the OBX Wave Report, and I will be back with you shortly from the beaches.